Hi guys, this is Saurav here and welcome to this master class of mine where we're gonna discuss 5 important concepts for IIT JEE relevant for 11th standard. Why we are taking these concepts is because these concepts are highly recurring. 11th स्टैंडर्ड में भी यूज होगा और फिर 12th स्टैंडर्ड में भी इनकी यूजेस रहती हैं और ये कंसेप्ट से हर साल एक ना एक क्वेश्चन आपका आएगा मेंस एग्जामिनेशन में. सो दीज 5 क्वेश्चंस अकाउंट्स फॉर लाइक 5 to 6 क्वेश्चंस इन द JEE मेंस एग्जामिनेशन. ओके, सो in this class we would be taking those 5 concepts which I feel to be most bothering to the students so that JEE भी आपका कवर हो जाए, JEE का कुछ पार्ट भी कवर हो जाए. Also from 11 to 12 transition also becomes easier. At the end of this session we have a surprise for you in terms of a highly demanded course which Vedantu is bringing so that you ace JEE very easily. Okay, so without wasting any more time, let's dig into the class. For people who do not know me, I am Saurav Goswami. I have done my masters from NIT Rourkela and this is my 10th year of teaching, and I've been teaching with Vedantu for quite a while, and this is my master class where I'll try to help you understand these 5 concepts which I feel are quite very important for the IIT JEE curriculum. Let's dig into the concepts. So the first, our flow for the day would be that we would be covering these concepts. The concepts are, the first one is hybridization, very important concept, हर जगह यूज होता है. Hybridization अगर आप नहीं जानते हो, you do not know like almost 50% of the chemistry. Degree of dissociation, next geometrical isomerism, Markovnikov rule, and peroxides and superoxides. Let's look at these concepts one by one. So our first concept of the day is hybridization. What is hybridization? Hybridization is a method of mixing of atomic orbitals so that new orbitals are formed which are equivalent in all regard. Why I'm saying equivalent? क्योंकि कुछ minor differences होते हैं and you can browse onto our sprint video series in which I and some other teachers have also discussed how are the hybrid orbitals. They are slightly different in the bonds which are formed, but more or less if we try to identify the hybridized state of any atom, the most easy way to do that is to calculate the number of sigma bonds connected to that atom and also the number of lone pairs which are present on that very atom. Okay, let's try to use this concept in solving hybridization of certain atoms in this case, or in these 3 structures. So what I was trying to say is hybridization is equal to number of sigma bonds and number of lone pairs, and let's see how this helps us in solving hybridized state for such atoms. The first structure that we would be taking is this one. This is the structure of nicotine. Okay, so let's start with nitrogen. Nitrogen has formed 3 bonds, but nitrogen has 5 electrons in its valence shell. Why? It is a member of p block, and p block में जितने s orbital और p orbital में electrons होते हैं वो आपके valence electrons हो जाएंगे. Hence, the outermost s number of electrons in s and p will be equal to the number of valence. So configuration is 2s2 2p3. Number of valence electrons will be 5. So 3 are utilized in bond formation. 2 would be present as a lone pair, a single lone pair. So a single lone pair plus 3 turns out to be a sum which is equal to 4. So this will be sp3. Okay, this carbon, this carbon, this carbon as well as this carbon. अब नंबर ऑफ बॉन्ड्स काउंट कीजिए. जो बॉन्ड्स दिख नहीं रहे हैं वो हाइड्रोजन के साथ होंगे. ओके, ये बॉन्ड्स हाइड्रोजन के साथ प्रेजेंट है क्योंकि कार्बन को टेट्रावैलेंट मुझे बनाना है. सो ऑल ऑफ दीज कार्बन एटम्स आर sp3. This nitrogen atom, lone pair of electron, 2 sigma bonds, 1 lone pair of electron, sum is 3, and that makes it sp2 hybridized. all of these are also sp2 hybridized, because you look at the carbon atom, each carbon atom is forming 3 bonds which are visible, and 1 bond is present with hydrogen, and this bond with hydrogen is a sigma bond. A double bond contains 1 sigma and 1 pi. So आपके पास 3 सिग्मा बॉन्ड हो गए, कोई लोन पेयर नहीं, टोटल काउंट इज इक्वल टू 3, hybridized state is sp2. If we look at this point, this is a CH3 group. If the bond terminates, and at the point where it terminates there is no hydrogen atom, that means there is a methyl group, and a methyl group connected to a nitrogen, the hybridization would be sp3. If we apply this on the rest of the 2 molecules, we would find that there are certain atoms which are sp3 hybridized and certain atoms which are sp2 hybridized. So let's look at this molecule. So 1 2 3 4 5 6, okay, 6 atoms which are sp3. 1 2 3 4 5 6, ये ब्लैक से जिसको हमने सर्कल कर दिया है, ये सारे हो जाएंगे sp2, एंड दिस वन is a CH3 unit which is also sp3. It's very easy, आप कैलकुलेट करके आप आइडेंटिफाई कर ले सकते हैं. All of these are sp3, 4 bonds and all of them are sigma bonds. Oxygen is sp2, 1 sigma and 2 lone pairs would be present, so it will be sp2 hybridized. This structure is also pretty interesting, इसमें भी आप निकाल सकते हैं. So nitrogen, these 2 nitrogen atoms look like they are sp3 hybridized, but they are not sp3 hybridized. Always remember, when an atom contains a lone pair adjacent to a bond, adjacent to a double bond, adjacent to a double, nitrogen, an atom contains a lone pair adjacent to an atom which contains a double bond, this will also be sp2 hybridized. This will also be sp2 hybridized. ये बाद में पढ़ोगे, इसको बोलते हैं इफेक्ट नोन एज रेजोनेंस. रेजोनेंस के कारण इसके लोन पेयर्स इसके ऊपर प्रेजेंट नहीं रहते, दे आर नॉट कंप्लीटली प्रेजेंट ऑन नाइट्रोजन. दिस इज आल्सो sp2, दिस इज आल्सो sp2, दिस इज sp2, दिस इज sp2, ये भी sp2, 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 sp2. All the blue ones are sp2 hybridized. All the blue ones are sp2 hybridized, and these 2 are sp3 hybridized. Very simple concept, very easy to understand. Most of the cases में आप आराम से निकाल सकते हो. Take a very large complicated molecule and try to identify hybridization of each and every atom by following this method. Okay, let's move on to the next concept. The next concept is about degree of dissociation. Now, what is degree of dissociation? Degree of dissociation is the amount dissociated per mole of reactant which is taken. Okay, if a substance is undergoing dissociation, then for every mole of reactant which is dissociated, we calculate degree of dissociation. Okay, so it is calculated per mole of substance. Now, there are various ways to do it. Let's look at some ways. Okay, so I will take this thing in a few cases. So let's take case 1. Let's take case 1. In case 1, I take NH3 which dissociates to form N2 plus 3H2. Okay, NH3 dissociates from N2 plus 3H2. I start with 1 mole of this, and this becomes 0, and this is 0. Initially 0 0 है. अब हमने क्या किया, इसको dissociate करवाया, 2x, ये x बना, ये 3x बना. Now remember, when I dissociate it by a certain amount x, this extent to which it is dissociating and the extent to which nitrogen and hydrogen is formed should be in the mole ratio. Why? 2:1:1. अगर 2 units dissociate करता है तो 1 unit इसका बनेगा and 3 units of this would be formed. This will be a constant feature irrespective of the fact that how much ammonia you are taking. Just because 2 is written in front of it, that does not mean that I need to purposefully take 2. I have to take 2. That's not a requirement. Depends on the question. आप 2 ले सकते हो, 1 ले सकते हो, 3 ले सकते हो, 5 ले सकते हो, कुछ भी ले सकते हो. But the amount to which it is dissociated and the amount to which nitrogen and hydrogen would be formed will always be in the mole ratio. So 2x, x and x, 3x. Sorry. Okay. So now I want to calculate alpha. Calculation of alpha is pretty easy. Alpha is calculated per mole. Okay. Alpha is calculated per mole. So how would I calculate alpha? Alpha will be how much of substance is dissociated? 2x. For how many moles of substance which is taken? 1. So alpha will be equal to 2x by 1, which is 2x. Cool. Very easy. इसको हम और एक तरीके से लिख देते हैं. This is 1, this is 0 and this is 0. Now I want to write the amount dissociated in terms of alpha, where alpha is the degree of dissociation. X is not degree of dissociation. X is some amount by which it is dissociated. But I have expressed alpha in terms of x. अगर मुझे alpha के terms में लिखना है तो मैं कैसे लिखूंगा? 1 minus alpha. क्यों? Alpha is equal to 2x. So this will be written as alpha by 2. And this will be written as, बताइए, if alpha is equal, if x is equal to alpha by 2, this will be written as 3 alpha by 2. Both of these representations are correct. Both of these representations, this is also correct, this is also correct. Okay, it's very easy, very very interesting, very easy. इसमें मैक्सिमम लोगों से गलती होती है, बट इसको आप समझ लीजिए. पर्सनली माई फेवरेट इज टू राइट इन टर्म्स ऑफ एक्स, क्योंकि आप उससे अल्फा निकाल ले सकते हो बाद में. ओके, लेट्स लुक एट अनदर केस. सो आई टेक केस 2. I take the same equation, NH3 to NH3 changes to N2 plus 3H2. Okay, so rather than taking 1, let's take we take 2. कुछ भी ले सकते हैं, यहाँ पे 0 और ये 0. I can write 2 minus how much of the ammonia will be dissociated? 2x, x, 3x. Because मैंने पहले आपको बता दिया कि आप 2 लो, 1 लो, कुछ भी लो, this amount dissociated will always be 2x, formed will be x, formed will be 3x. Okay, what will be value of alpha? 2x is dissociated for how many moles? 2 moles, so it will be x. Okay, so somebody wishes to write it like this: 2 0 0 and wants to express x in terms of alpha, so can be written as 2 alpha, alpha, 3 alpha. Both of these expressions are correct. Somebody who is writing it like this is also correct. Somebody who is writing it like this is also correct. Okay, let's look at case 3. Case 3 is same equation, but let's say we take 3 moles of this. Rather than taking 1, 2, मैंने क्या ले लिया? 3 ले लिया. So ये initially 0 and 0. Again 3 मैंने लिया है, but amount which is dissociated will be independent of how much is taken. So I'll write it as 3 minus 2x. और ये कितना जाएगा? x, and this is also 3x. Understood? Now try to calculate alpha. Alpha is calculated for 1 mole, so 2x is dissociated for 3 moles. So 1 mole के लिए कितना होगा? 2x by 3. Okay, alpha is equal to 2x by 3. Clear? So if somebody wishes to express it like this, 3 0 0, और ये अल्फा के टर्म्स में अगर लिखना चाहता है, then हम क्या करेंगे, x को लिख सकते हैं 3 alpha by 2. I put the value of x over there, it will become 3 alpha. Okay, 3 alpha by 2, this will become 3 alpha. This will become 3 alpha by 2, and this will be 3 alpha by 2, 9 alpha by 2. Clear? So this is how we would write it. This expression is also correct. This expression is also correct. This, I guess, has clarified a bit of your doubts regarding calculation of alpha. Prefer to write it like this. From here you can calculate alpha very easily. Okay, let's move on to our next question. So our next concept is on geometrical isomerism. Question is, how do we identify if a compound exhibits geometrical isomerism or not? Okay, now geometrical isomerism is generally expressed in planar molecules. इसको आपको याद रखना है. It is exhibited in molecules which are flat. Okay, so which of the following molecules will exhibit geometrical isomerism? Let's take some molecules. Let's take this molecule, CH3, C, CH3, double bond C, H, H. Okay, so how do we identify this? The best way to do this thing is, you assume the molecule to be present in a plane of paper. एक plane पे आपने रख दिया है. Assume that you have placed it in a plane of paper and take this axis. Fix one part and rotate the other. Fix one part. Let's say आपने कार्बन, हाइड्रोजन एंड हाइड्रोजन को फिक्स कर दिया. इस प्लेन में कार्बन, हाइड्रोजन एंड हाइड्रोजन फिक्स्ड हैं एंड दिस कैन बी फ्लेक्स्ड. So I rotate this by 180 degrees, always by 180 degrees. Fix one part and rotate the other by 180 degrees. If I get another structure, अगर हम इसको 180 डिग्री से रोटेट करते हैं तो क्या होगा, CH3 यहाँ चला जाएगा. Am I getting a different arrangement? No. So this compound cannot show geometrical isomerism. So remember, take the molecule, fix it on a plane of paper, fix one part of the molecule on the plane of paper, rotate the other part by 180 degrees in the rough. If you are getting a different arrangement, that means it can show geometrical isomerism. Always applicable for alkenes and cycloalkanes. Let's take another case. CH3, Cl, double bond CBr. I suppose this. I have to identify what will happen. I fix one part and rotate the other part by 180 degrees. What will I obtain? Let's say this is being fixed. So I'll write it like this. जिसको फिक्स कर दिया उसको वैसे ही रहने दो, कोई चेंज करने की जरूरत नहीं है. दूसरे पार्ट को आप इस तरह से लिख सकते हैं, Cl, CH3. Are you getting a different arrangement? Yes. So that means they can show geometrical isomerism observed. Very easy. Simple concept है, इसी को लगाना है. ठीक है. Let's look at a different set of molecules. ये तो हो गया आपके open chain molecules के लिए. If you want to identify it for a cyclic molecule, cyclic में भी हम यही रूल लगा देंगे. So मिथाइल, मिथाइल, यहां पे एक हाइड्रोजन है, यहां भी एक हाइड्रोजन है। फाइन, एक पार्ट को फिक्स कर दीजिए, लेट्स से ये फिक्स दिस पार्ट, ट्राई टू रोटेट दिस by 180 degrees, mentally try to rotate this। अगर आप mentally ही rotate करोगे तो आपके पास क्या स्ट्रक्चर मिलेगा? Okay, there is not a real rotation, it's a mental rotation। You'll get something like this। Are the two structures different? Yes, that means this rotation is not allowed। ये rotation allowed नहीं होता है, लेकिन हम mental rotation ये कर रहे हैं। mentally हम सोच रहे हैं कि ये इस तरह से अगर rotate करता तो क्या बनता? So, am I getting a different structure? Yes, so both of these are geometrical isomers। This is the concept। This is a very easy concept। Fix one part of the molecule, rotate the other part, आपको geometrical isomer मिल जाएंगे। Let's take a slightly difficult one। So, ये एक मॉलिक्यूल होता है which is known as allene। A number of you might be aware of what an allene is। Okay, so rather than taking this as methyl, let's take this as chlorine, bromine, iodine। Okay, now point is, the molecule, this whole molecule is present in a particular manner। This point is this one। Okay, कार्बन यहां पे हो गया आपका ब्रोमीन, यहां हो गया आयोडीन। दिस इज वेयर अनदर is present। You can write methyl over here, you can write chlorine over here। Fine, now fix one part and try to rotate the other। Okay, fix one part, try to rotate the other। What you will get is a structure something like this। Cl, C, Me, double bond C, Br, I। Now what has happened is, though chlorine has moved on the other side, there is no visible difference because they are not present in the same plane। Since they are not present in the same plane, this molecule cannot show geometrical isomerism। Okay, this molecule cannot show geometry because the whole molecule is not present in the same plane। This part of the molecule and this part of the molecule are orthogonal with respect to each other। But if there would have been 3 such pi bonds present or 3 such double bonds present next to each other, there is a even number of double bonds। अगर odd number of double bonds होते इसी तरह से, then it would have shown geometrical isomerism। Try to work it out। Let me know in the comment section that if you have understood this part। Okay, let's move on to the next concept। The next concept is Markovnikov's rule। Markovnikov's rule is a very easy rule। Markovnikov's rule is something that you learn in organic chemistry, in alkenes, in the addition reaction। It is generally studied when a HX type of a molecule reacts with an alkene। So what is Markovnikov's rule? The Markovnikov rule suggests that the negative part of the addendum attaches itself to the carbon atom, which can form a more stable carbocation। What does this mean? So, if we know कार्बो, if you have learnt about carbocations, then carbocation की stability इस तरह से रहती है. Carbocation stability is benzylic, more than 3 degree, more than 2 degree, more than 1 degree, more than methyl. ठीक है. Now let's take a simple question. You have a molecule like this, CH3, C double bond, sorry, CH double bond CH2. This molecule is trying to react with HCl. Addendum is this. This is known as the addendum. इसका negative part क्या है? What is the negative part of this? This is the negative part. That means the anionic part. Now, if I attach HCl to this molecule, I first have to identify that if I break this double bond, addition होगा तो ये double bond break कर जाएगा. If this double bond is broken, where would a more stable carbocation be formed? So हम दो तरह का carbocation बना सकते हैं hypothetically. I can form this carbocation, or I can form this carbocation. Okay, assume कर लो कि इसमें से जो H plus part है वो किसी एक कार्बन के साथ अटैच हो रहा है and the other carbon is changing into a C plus unit. So if this H plus is getting attached to this carbon atom, this changes to C plus, the middle one changes to C plus. If H plus gets attached to the middle one, terminal one becomes C plus. Now where would Cl minus go and attach itself? Markovnikov rule suggests that the more stable carbocation is where it will react. So this is 1 degree, this is 2 degree. So where would it undergo attachment? It will attach itself over here so as to form the product, which is this CH3, CH positive, CH3, which will react with Cl minus to form CH3, CH, Cl, CH3. Very simple, very simple. Let's look at a different problem. CH3, CH3, H, CH double bond CH2. अगर इसमें रिएक्शन हम करा रहे हैं, ओके, सो if HCl is trying to react with this molecule, so remember guys that this carbocation would initially be formed. Why? Because H plus can attach itself over here or over here. कहाँ पे attach कराएंगे? Which gives a more stable carbocation? This a more stable carbocation. और carbocations एक feature होता है कि carbocations get a window period to become stable. Like examination से पहले last minute preparation होता है. So उसी तरह से carbocation also gets this small window period to become stable. So this small window period to acquire stability can be achieved by something known as carbocation rearrangement. Now this rearrangement involves migration of hydrogen, or better to say migration of hydride, methanide or pH minus unit. Now अब होगा क्या कि this you can see that there is a 2 degree carbon, 2 degree carbocation. Now this 2 degree carbocation will try to change into a 3 degree carbocation because a 3 degree one is more stable, and ये 3 degree बनाने के लिए हाइड्रोजन यहाँ से यहाँ आ जाएगा. So it will happen like this. This is known as 1,2 H minus shift. So जब भी आप carbocation देखें, and you can see that if the carbocation can be formed at the adjacent position where it can become more stable, shift करा दो. Okay? CH3, CH3, हाइड्रोजन को शिफ्ट करा दिया हमने. क्या कर दिया? This hydrogen has been moved over here. ये इसको हमने यहाँ मूव करा दिया. Now this carbocation will react with our Cl minus to form an appropriate product. Product would be CH3, C, CH3, Cl, CH2 CH3. Clear? So this is what Markovnikov rule is. You form the more stable carbocation and there you attach the negative part of the addendum. Now ये जो addendums होते हैं ये बहुत सारे forms में मिल सकते हैं. I can have HX where X is a halogen. We can have H2O. We can have ROH. In H2O the negative part would be OH. In ROH the negative part would be RO minus. Okay? Let's move on to the next concept. The next concept is the last one for the day, and that is about superoxides and peroxides. Now we will primarily be discussing superoxides and peroxides of group 1. And group 1 का superoxide and peroxide का एक simple बहुत important question आता है. Question ये आता है कि when you dissolve them in water, what is formed? Okay? Okay? So peroxide is written like this: O2 2 minus. Okay, O minus 1 minus 1. This is peroxide. Okay, and a superoxide looks like this: O2 minus 1. Okay, O2 minus 1. So superoxide and peroxide ये molecular orbital theory में भी पढ़ते हो. इनका बॉन्ड ऑर्डर भी हम कैलकुलेट करते हैं. O2 2 माइनस का बॉन्ड ऑर्डर हो जाता है कितना? O2 बॉन्ड ऑर्डर इज 2. 2 electrons are added in anti-bonding molecular orbital. Each electron reduces the bond order by 0.5. So O2 2 minus bond order is 1. O2 minus 1 bond order is 1.5. ठीक है? Let's look at what will happen if they are added to water. Superoxide and peroxide group 1 में बहुत कॉमनली मिलता है हमें Na2O2 के फॉर्म में सोडियम पेरोक्साइड एंड KO2 where potassium superoxide. This is known as sodium peroxide. This is known as potassium superoxide. Okay, when you add this to water, what will happen? I can write sodium peroxide as O minus, which is bonded to Na plus, bonded to Na plus. When it is added to water, then this O minus will try to bind with H plus, which is given by water, and Na plus will try to bind with OH minus, which is given with water. ये इसके साथ bind करने की कोशिश करेगा, इसके साथ bind करने की कोशिश करेगा. So what will be formed? Very easy. H2O2 plus NaOH. H2O2 plus NaOH. But potassium superoxide, if you apply the same logic, O2 2 minus has 2 unit of negative charge, so you combined it with 2 H plus ions. But in this case, if you try to do the same thing, so you'll get O2 minus 1 and you combine it with H plus, you will get HO2, which is something which does not exist. So how do we know this? How do we identify what will be happening? The method is very simple. What we do is, we remember this fact that O2 minus 1 disproportionates. Disproportionates means simultaneous oxidation and reduction. बहुत easy है निकालना. O2 and O2 2 minus में break कर जाएगा. Okay, इसको हम यहाँ पे 2 लिख देते हैं. It will break into O2 and O2 2 minus. It will break into oxide and peroxide. Okay, इन दोनों का देखो बीच का ऑक्सीडेशन स्टेट है -2 और ये 0 है, तो ये -1 पे आ रहा है. So this is what is going to happen. Now this will remain like this, but this will combine with H plus to form H2O2. So if you react this with water, the product would be H2O2 KOH plus O2, and पहले वाले में H2O2 and NaOH. Clear? Very simple reaction of oxide, peroxide and superoxide. इसके ऊपर हमेशा क्वेश्चन आते हैं and you can solve this very easily by remembering this simple funda. Okay, so what Vedantu is gonna bring to you in a form of a course is this. Vedantu is bringing you a JEE crash course and a 1-year long-term course, where JEE crash course for 11th will help bridging the gap between 11th and 12th. Your revision will be covered in a very small amount of time, so that आप 11th अपना आराम से दो, 12th में fully prepared होके आओ for a 1-year long-term course for JEE advanced as well as mains. The 1-year long-term course is very exhaustive, and the classes for that will start somewhere in month of April, and the classes can be taken up from anywhere. You can like watch it at your convenience, you can take the tests at your convenience, and all the lectures would be recorded, and all the lecturers will be available for your doubt clarification. There'd be like, you would not feel that you're not attending an offline classroom session, online classroom session, you're missing out on anything. Online classroom session will actually enable you to do a lot of effort, put a lot of effort in the self-study part. Okay, so this is the best course of Vedantu for a 1-year long-term program, in which you'd be taught by the best of the teachers using the best of the technology.